Hey guys, I'm really sorry about this. I know some of you really don't like learning from a video, but we're going to just try it, all right? Just because I have to be out today. So I apologize in advance, but just bear with me, all right? This is the problem that we were working on together in class yesterday. So make sure your packets are open up to this page so that we can continue working on number 4. And I'm just going to restart and explain it all again and then finish up with the problem, and then we'll try another one. Cool? So this is asking us to find the slope of the curve at x equals a. Remember that the slope of the curve is just a fancy way of saying the slope of the tangent line. Okay, slope of the tangent line. Tangent line. Don't worry guys, I can spell. It's okay. We're good. So, if I know that I want to find the slope of the tangent line, the first thing I'm going to have to do is write down my formula. All right, so slope is m. So m is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. This is something that we are going to work with time and time and time again, all right? So I know you don't have it memorized yet. I don't expect you to have it memorized yet, but we wrote it down in our notes a couple of times already, okay? So we got that. Now what we need to do is we need to figure out what we need to plug in, right? So we are looking at the slope where x equals a. All right, so what I'm going to want to do is anywhere that I see an x, I want to now put in this a instead. So everything else stays the same. It's still the limit as delta x approaches 0 of f of, instead of x, I'm going to put a plus delta x minus f of a all over delta x. Literally the only thing that changed from step 1 to step 2 was I took out the x and I put in this a. All right, if that was a number, I'd put in the number, right? In the last example that we did, we were putting in a 2 because I told you x equals 2. Well, now I'm telling you that x equals a. All right. Then we need to look at this function, right? So go back up at the top and look. F of x equals 1 over x. Which means if I want to plug in a, that means I want f of a. It's just 1 over a. And I know we had a little bit of a discussion about this in class, but I'm talking about it again, all right? So f of a just means, hey, plug in a instead of x. Cool. 1 over a, I'm good to go. Then I want f of a plus delta x. Well, again, it just means plug that in for x. So it's 1 over a plus delta x. Well, now when I look at my formula, right, f of a plus delta x, well, I just said that that's 1 over a plus delta x. And f of a, well, I just said that's 1 over a. So I'm going to plug those in, all right? Now I'm going to go with the limit as x approaches 0, sorry, delta x approaches 0 of, instead of f of a plus x, I'm going to plug in 1 over a plus delta x minus, instead of f of a, I'm going to plug in 1 over a. And then it's all over delta x. All right. And I think that is kind of where we left off in class. The only other thing that we then started to talk about was that this looks awfully similar to some of the limit problems that we were doing in chapter 3, where we had to find the LCD, right? So we did start talking about that a little bit, and I think the last thing I did was actually write that we were going to multiply by the LCD. So the LCD is a times a plus delta x, so I'm going to do that here. And I'm going to do it here. All right, that LCD gets multiplied on the top of all my pieces there. And we luck out because we get some stuff to cancel. So here, those cancel each other. And here, my a's cancel each other. So now I have the limit as delta x approaches 0 of a minus a plus delta x all over delta x times a plus delta x. Notice the denominator didn't change. I'm not going to distribute. Oops, I got to move that so you can see, so that you can notice the denominator didn't change. How about that, Miss J? My denominator did not change at all. It's still delta x times a times the quantity, a plus delta x. On the top here, those two pieces canceled, so I was left with my a. I had a minus sign. Those a's canceled, and I was left with a plus delta x. Make sure that's in parentheses, because now we have to distribute and keep simplifying. So the limit as delta x approaches 0 of a minus delta x all over delta x times a plus delta x. And hopefully you guys see that those a's cancel pretty nicely right there. And we have the limit as delta x approaches 0 of negative delta x over delta x times a plus delta x. And I still can't plug in this delta x yet. I still can't plug in 0 for delta x, right? Because I have a delta x on the bottom. But hopefully you guys see that those delta x's cancel and I'm left with this negative sign up front. All right, don't drop it. Limit as delta x approaches 0. Now I have a negative 1 over a times a plus delta x. Now, if I plug in 0 for delta x, now I think I'm actually okay. So let's do it. Now I'm going to have negative 1 over a times a plus 0. That's okay. I can do that. Now it's just negative 1 over a squared. That is the slope of the tangent line at x equals a. So m equals negative 1 over a squared. That's the slope of the tangent line at x equals a. So now the nice thing is any a value that I pick, I can just plug it in there and I have the slope at the tangent. It's pretty cool, I promise. I know it seems a little overwhelming, but I do promise you that this is some pretty cool stuff. Okay? So now look at part B. Part B asks us, where is the slope equal to negative 1/4? Well, we just did all of that work and we came out with the slope is equal to negative 1 over a squared. All right, well, I want the slope to equal negative 1/4. Cool, that's what I'm going to make m. Negative 1 over 4 equals negative 1 over a squared. Just cross multiply and solve for a. Negative a squared equals negative 4. Divide by a negative 1, and we get a squared equals 4. Take the square root, so a is going to equal plus or minus 2. So at either x equals 2 or at x equals negative 2, we will have a slope that's equal to negative 1 over 4. But see how nice and easy that was once I found this general formula down here, right? So all this nasty work that I had to do got me a formula, and now I can find the slope at any point. Now I can just plug it in, right? So I know there are a couple more problems in your packet for us to do. We're going to talk about those on Friday when I'm back. All right, so for now, I want you to skip ahead just a little bit and go to the page that talks about the derivative of a function. All right, so I think it's like 2 pages later in your packet. So the top of the page says derivative of a function. Okay. This is a key thing in calculus. All right, I know I keep telling you guys, oh, we got to have all these algebra skills, algebra skills, algebra skills. This is where we're going to actually do some calculus now. All right. So when we find the instantaneous rate of change for a function at a specific point, we call this value the derivative of the function. All right, so the derivative of the function. To calculate the value of a derivative at a specific point, you guys ready for this formula? first of all, I'm going to just call it for now, and I'll explain later. I'm going to call it f prime of x. We'll talk about notation and stuff in a little bit, but for now, just bear with me. All right, the derivative, we are going to use the formula limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. It's the same formula, guys. It is the exact same as finding the slope of a tangent line. Okay, I'm just calling it something different. So finding the slope of a curve at a point, finding the slope of the tangent at a point, and finding the derivative all mean the exact same thing. Okay, so take a look at this first example. Calculate the value of the derivative of the following functions at a given value. So we're going to use this formula. The derivative is equal to the limit as x approaches 0, delta x, Miss J, of f of x plus delta x minus f of x all over delta x. So cool, I got my formula down. Now I need to actually see what my function is, right? Because I kind of skipped over that. So f of x is equal to 1 over x, and we are looking at x equals 2. So just like we were doing in the last problem, first thing we're going to do though is plug in this 2 for x. So I'm going to get the limit as delta x approaches 0 of f of 2 plus delta x minus f of 2, and I will move this over so that you can see, all over delta x. And now we have to think back to, okay, what does this f of 2 plus delta x mean? It means plug in 2 plus delta x. So f of 2 plus delta x means plug that into my function. Well, my function is 1 over x. It's right here. So it means 1 over 2 plus delta x. And what about if I asked for f of 2? That one I know you guys are comfortable with. F of 2 means plug in 2. Cool. That means 1 over 2. All right, so now we are going to get to plug that stuff in. So f prime of x equals, I want my f of 2 plus delta x, that was this one, 1 over 2 plus delta x, and then minus f of 2, so minus f of 2 is right here, it's 1/2, all over delta x. Sorry, I had to think for a second there. Okay, I really hope that as I'm doing this, you guys are thinking, hey, this looks really, really familiar. We just did this, didn't we? When we did problem 4, just now in the video, I was doing this exact same thing, but I was doing it at A instead of 2. All right, so what I want you guys to do is you are going to finish this problem. All right, work with your groups, work with each other. I don't care if you guys do it up on the board, if that's what you're more comfortable with, but I want you guys to finish this problem together, and I want you to find the value of the derivative, and you should get to an answer. Are you ready for this? You should get that f prime of x is equal to negative 1 over 4. You guys want to know how I know that? Look back in your notes to what we just did. Let me find it real quick. Remember all this stuff that we just went through for number 4? Well, it's the same function, 1 over x. And I asked you on part B, where does the slope equal negative 1 over 4? And we said that, hey, that's when a is plus or minus 2. Look at the problem you're looking at right now. Same function, and I'm asking you at x equals 2. So when you guys perform all the necessary algebra here, you should get down to, ooh, Miss J, you forgot your limit notation here. Limit as delta x approaches 0. Sorry. Once you do all of the algebra and then you plug in your value for your limit, you should get negative 1/4. So I want you guys to work together on that. Like I said, I don't care if you do it on the board. You can do it in your groups. You can do it individually. Whatever works for you guys. You guys decide as a class. Get that answer done. And then I would like you guys to work on question 2 as well. Okay, there are, I believe, more if need be, if you finish those ones and need some more to work on. But I want you guys to take it nice and slow, work through it together, make sure you guys are understanding where all of this is coming from. Hopefully that makes sense. I know some of you don't like learning from a video, but do your best. At least copy down the notes that I did, give it a shot. And especially work on numbers 1 and 2 as a class and see what you guys can get. And when I am back on Friday, we will touch base and see where we're at as a class, okay? All right, I will see you guys on Friday. Bye.